Good afternoon, sir. Good afternoon, Pundalik, sir. Good afternoon, sir.
Good afternoon. My voice is clear?
Okay, sir. Okay, sir. Good afternoon, sir.
Good afternoon. Good afternoon.
Sir. Good afternoon, all.
Good afternoon.
I heartily welcome to Atal Online 6 Days FTP Session 12. Now I request I heartily welcome Dr. Yogesh Yashwant Pundalik, sir. Now I request K. Sujata, madam. Please introduce today's resource person, Dr. Yogesh Yashwant Pundalik, sir.
Okay, sir. Thank you, Anil, sir, for giving this opportunity. Good afternoon, all. Myself, K. Sujata, Assistant Professor from EEE Department. It's my pleasure to introduce Dr. Yogesh Yashwant Pundalik, sir. Sir has completed his PhD from JNTU, Kakinada, Andhra Pradesh, MTech from JNTU, Kakinada, and Bachelor of Engineering from Nagpur University. Sir completed various NPTEL courses like Sensors and Actuators, Introduction to Industry 4.0 and Industrial Internet of Things, and Hydrogen Energy. Sir has published 31 papers, in that National Conferences 16, International Conferences 6, National Journals 2, International Journals 7. Sir's areas of interest: hydrogen energy, transport and utilization, condition monitoring of high voltage power apparatus, solar and other renewable sources integration to grid. Sir received Best Reviewer Award for the year 2020, Best Paper Award in National Conference, Best Paper Award in International Conference, 2 papers published in IEEE Explore. Sir is a member of ISTE, Instrument Society of India, Solar Energy Society of India, International Association of Engineers, Sir is a senior member of Hong Kong Chemical, Biological and Environmental Engineering Society and professional member of Institute for Engineering Research and Publication. Sir worked as additional academic in charge, officer training and placements, officer in charge of examinations in Kamala Institute of Technology and Science. Presently, sir working as head department of Tribly, college coordinator for JNTUH, in charge of Renewable Energy Committee in Kamala Institute of Technology and Science. I happily welcome you, sir. Thank you. Thank you, one and all.
Thank you, Sujata madam. Now I request, please hand over this session, sir.
Good afternoon, one and all.
Good afternoon, sir.
So, shall I start presentation?
Okay, sir.
Okay. If it is visible,
Okay, sir. Visible.
okay, I will go to the first slide.
Okay.
You can take some screenshots afterwards, okay, when the session is going on. It's a request from my side. Okay. So, on my personal behalf, I would like to welcome all the participants for Atal Online 6-day faculty development program on artificial intelligence applications in renewable energy sources. And today is the last day, 14/12/2024, and session number 12. My topic today is development of AI and ML models for renewable energy optimization. So thank you, Sujata madam, for my introduction. In addition to this, I would like to say that I'm the governing council member of Solar Energy Society of India. I'm representing Telangana state in that. And also I'm working as a Dean of Student Affairs in my college, in Kamala Institute of Technology and Science. So now I'm starting. This is the outline of my presentation. So today we'll have the introduction to renewable energy. What is renewable energy? Already the participants may be aware about this renewable energy and other things, because this is the last session. Voice is clear?
Okay, sir.
Any problem is there, you can tell me, you can stop anytime. Second slide is visible?
Yes, sir.
Okay. Anything is there, you can talk to me. Okay. So in introduction to renewable energy, so being this is a 12th session in the FDP, I think my job is easy, and I would like to also discuss about the artificial intelligence and machine learning techniques in the renewable energy optimization. First, we will see what are the challenges in the renewable energy optimization, role of AI and machine learning in energy systems, and then what are the applications of AI/ML in renewable energy optimization. Some few 5 to 6 case studies are there, so those case studies we will discuss, and real world applications, and what are the challenges of AI applications in energy sector at the end. Then after this, last 2 slides will be for the emerging or future trends in renewable energy, AI applications, and lastly the slide is conclusion. So these are the sections of my presentation. Around 6 to 7 sections are there. One by one we'll see. Each section will have 2 to 3 slides. So introduction to renewable energy. What is renewable energy? You know everyone that we are getting new sources of energy. Why there is a requirement of new energy sources? Because the conventional sources, like for example coal and petroleum products, they are going to be exhausted after a few years, and therefore we have to choose the new sources. because once the petrol is completed, or diesel or petroleum products are completed, or the coal is completed, then everything may stop. So we are searching, like human being is searching for the new energy sources. So best source is solar, then followed by wind. We have hydro, and then geothermal to some extent, maybe around 2 to 3% of overall global energy market. Hydrogen is coming up, and biomass. Apart from this, we have got sustainable sources like which are replenishable naturally. For example, the algae is also coming up as one of the energy source. So importance of renewable energy, why we require to go for renewable energy? Mitigating the climate change. So to reduce the effect of the climate change, we are going for renewable energy. And we have to move away from the fossil fuels. Just before 2 minutes, I told you that petroleum products and coal mines or coal shortages we are facing, and coal may be completely exhausted after few years. So we have to search for new and reliable sources, and the fossil fuel reliance we have to reduce. So we should not completely depend on the fossil fuel nowadays, and therefore we have to go for reduction of the reliance on the fossil fuels. Increasing the energy security is also issue, and then global energy growth. For example, statistics show that there are renewable energy adoptions are going on throughout the world. There is a Green Grid Association that is called as GGG, Global Green Grid Association. So with that initiative, solar energy or wind energy may be transmitted from South Africa to any other country like India, or if it is generated in India, we can transmit to the other parts of the world. So that initiative is being taken up under the leadership of our Prime Minister, PM Modi sir. So around 140 countries have signed the Green Grid Initiative, Global Green Initiative. So this is additional information regarding the global renewable energy growth. It is growing continuously every year. And then why we are shifting? Because there is a pollution problem of thermal power plants, and therefore we have to think about the cleaner, greener and other energy sources. So generally the renewable energy sources are clean and they are green. Green means CO2 emissions will be minimum or negligibly small. We can neglect it also. So what is AI? Artificial intelligence. Basically they work on the neural networks. Why we are using? This is a figure, interesting figure, first figure. So where we require AI? Because the renewable energy sources like solar, wind, hydrogen, and hydro, like availability of water, these are dependent on nature, and they are intermittent. Like wind flow is not continuous with the same speed. Sun energy is also daily. Morning, if you see, the intensity will be less. Around afternoon, 12 o'clock, intensity will be more. In the evening, again, intensity will go down. Sometimes we get the solar day or sunny day as a morning 6 to evening 6, evening 4. Sometimes we get morning 6 to or 7 to 5. So it depends on the nature, and all these renewable energy sources are dependent on nature. So they are intermittent. It's not continuous. Like it is not like a thermal power plant that we can use it for a base load applications. So majority of the demand will be fulfilled by renewable. Still it is to be achieved. It is a goal to be achieved. So numeric weather forecast that we have to consider, like it will be given to the artificial neural networks. Weather data from the measurement like NASA or other data that can be given, and historical data on the production of the wind or other sources that will be given as input. So these are the three inputs. On the left hand side, you can see this is weather forecast, and just 1 minute. I am taking pointer. So this is numeric weather forecast. Weather data from the measured values or the past data or from satellite availability, satellite data, and then historical data on the production of the energy sources. So all these three inputs will be given to the artificial neural networks. What these artificial neural networks will do, that is, they will forecast the production and combination of the productions like solar and wind majorly, that will be put together or aggregate value that will be given as a output. Even we can say that the production forecast can be done for like next 24 hours or next 48 hours or up to 10 days. So next 10 days, today is say 14th December, then up to 24th December we can make the prediction, or we can do the forecasting of the production of the renewable energy power or energy values. So these are the different models. Artificial neural networks we can use. Power curves is another requirement, and then ARX models. So all these models put together, they will be used for forecasting the aggregated value of the different sources, and that is based on the weather data. Then what AI can control? So this is another interesting figure. What AI can control? This is a general diagram basically. It's not related to only renewable energy sources, but energy sector as a whole. So in this we can see the solar PV modules, then wind energy also we can see sources, and the power station like conventional power stations, thermal power plant, we can see the chimney there. And then the smart homes also can be controlled by AI. Industries, manufacturing industries and other industries also can be controlled by AI. Commercial buildings or commercial activities also can be controlled by AI. And then we have the smart subways, for example, the logistics. So transport and logistics also can be controlled by AI. So these are all the possibilities what AI can control. Then what is the role of AI in renewable energy technology? RET means renewable energy technology. So we can use the AI, artificial intelligence, for grid integration and stability of the grid, predictive maintenance. For example, the wind turbines are there. So sensors can be kept in the wind turbine as well as on the blades and other places in the wind energy farms, so that any maintenance required in future after say 3 days or 4 days, the sensor will tell you that so and so the problem may arise at so and so place, either in the turbine or inside the turbine, like for example induction generators. So based on that we can take up the maintenance well in advance before the final failure occurs. So this is called as predictive maintenance. And then cost reduction. So cost also can be reduced, cost of the production and cost of the inputs, or whatever we can say that input to the sun energy like solar, tracking of the sun energy, that also can be done. So we can reduce the cost. Overall cost of the maintenance can be reduced. Also the AI can be used as a advanced control system. So automation of the microgrids, we will discuss after say 15 or 20 slides. At the end of the session, we have one slide on the success stories. So in that we will discuss about that, how it will be automated. Energy storage optimization also can be done. This is a very big area in which researchers can work, and anybody wants the research or PhD suggestions. So you can take this as a suggestion: energy storage optimization, optimal research allocation. So resource we have to allocate, like wind turbine. if so for example, the location is not properly chosen, then it may be a complete failure of the wind farm or wind energy solution. So we have to select the site. Site selection is also important. Site selection of the solar power plant also very important, and other energy sources also important. So optimal resource allocation, and which resource you have to use at what time, that we have to choose properly. So for example, the solar systems will not be available in the night time. So therefore we have to go for energy like dependency on wind farms, because wind may be available at the night time and sun is not available at night time. So we have to rely on wind. So this is called as the optimal resource allocation. How to allocate the resource for which demand, etc. So demand side management, etc. All these things will come in this optimal resource allocation. Then we have got next figure is related to the renewable energy sustainable options what we have, or energy sources what we have. Solar energy is there, wind energy is there, hydro energy is there. So pumped storage power plants will be considered under the renewable, because the water which is available at the tail race, again that will be pumped in to the main reservoir, and then based on that we can generate the electricity using the same water. So this is hydro energy. Then tidal energy, you know very well. In the ocean we can keep turbines, vortex systems, and then we can get the generation. So for this we can use the machine learning and deep learning techniques for all the resources. And finally, what we are able to do is energy conversion, optimization of energy conversion, optimization of the forecasting also perfectly can be done, and then power prediction also can be done. So what is the output of all the sources that can be, information can be gathered at one place. So that is called as the power prediction. Then apart from this, the second diagram is the randomization of based on the machine learning model. So randomly which energy source we are going to use. For example, solar energy is used, or wind energy is used, or marine or ocean vortex type of tidal system we have to use, or hydro power we have to use, or other sources of energy like hydrogen we can use, biomass we can use. So this will be allocation can be randomly done based on the machine learning model. And the energy mix, now if you choose one energy, it will give the output power to some demand. It may not fulfill the total demand. So therefore we have to go for energy mix. So put together all this, we will get the output as a randomization of the allocation of the sources. So either 2 to 3 sources or 5 sources depending upon the peak demand or energy demand in the system. So next one is, what are the challenges in renewable energy optimization? So intermittency and variability. So just now I told you, just before 10 minutes, that solar and wind are weather dependent, and there are some challenges. So when the weather changes, then solar and wind, both the sources, they will change the output. So therefore this is called as intermittency. And wind is also not continuously available, so it is going to vary. The energy output of the windmills or wind farms is going to vary. Therefore it is called as variability. And there are some challenges in ensuring the consistent supply of the power to the demand or the loads. Then next challenge is energy storage. So we need to go for effective energy storage solutions to balance the supply and demand. And there are certain limitations on batteries. So even 50 kilowatt, suppose somebody is having solar power plant, we are unable to store because the battery size is very big. You require separate room for 50 kilowatt. Then beyond 50 kilowatt, like 100 kilowatt, 200 kilowatt, the question doesn't arise that we are going to store the energy. So these are the limitations of batteries and grid storage technologies for the energy storage. So this is the challenge in optimization of the renewable energy. Next challenge is grid integration. So all these renewable energy sources are intermittent. In the first point, we have seen that there is an intermittency property is there for all the renewable energy sources, and therefore connecting to the grid is a very big challenge. And maintaining the grid stability with the variable power sources is also a big challenge. So these are the challenges in the grid integration. Integration is a separate subject. How to integrate the renewable energy sources? You require to have frequency same, and then the voltage level should be same. Voltage should not fluctuate. All those conditions of the parallel operation of the alternators that we should be satisfied. So we can think of the solar as one of the generator and wind as one of the generator, and then we are going to connect them in busbar like existing system. So that is called as grid integration. So it is a big challenge to maintain the stability of the grid. Power stability and voltage stability, both power angle stability and voltage stability, both we have to maintain. It is a challenge. And then operational efficiency. So optimizing the power generation and distribution, minimizing the cost while maintaining the reliability. So this is we have to have the balance between the cost should be less as well as the reliability also you have to maintain, efficiency also you have to maintain. So all these things we have to, as an electrical engineer, we have to balance things. And therefore, this is another challenge, or we can say that one of the important challenge in optimization of the renewable energy. Then what is the role of AI and machine learning in energy systems? To get the balance or to overcome these challenges, 2, 3, 4 challenges, what is the role of AI? So artificial intelligence is a big subject. So use of the algorithms and data-driven models for taking the decisions and predicting the outcomes and optimizing the operations, that we can do with the help of artificial intelligence. Now, what is the use of machine learning? Machine learning is a subset of AI that enables the systems or computers to learn from the data and improve over the time. So we can give the intelligence to computers using machine learning algorithms or machine learning models. That is how the artificial intelligence and machine learning is going to work. Now, how the AI and ML, artificial intelligence and machine learning, how it helps? It helps in predicting the modeling to forecast the energy production. So energy production is a big issue, or we can say that it is one of the challenge. How to make it stable, and what is the forecasting of the energy production. So next 24 hours, what will be the power production of solar plant, that we have to predict. For that, machine learning models are available, and we can do our own models, and then we can forecast. Next, intelligent grid management and the demand response systems. So demand side management is another different subject that we are going to, the idea here is that we are going to reduce the demand or to manage the demand such that the renewable energies sources will be sufficient. And for that also we can use artificial intelligence. And when we use artificial intelligence for managing the demand side or power demand, then we can call that as a intelligent grid management. Then optimizing the energy storage systems and enhancing the efficiency in operations. So these are the areas in which the artificial intelligence and machine learning will help to optimize the energy storage system. So optimizing the energy storage systems, the AI and ML can help. Artificial intelligence also can help in enhancing the efficiency in the operations while the systems are being operated. So what is the role? Again, we'll take up the next slide. That is another interesting 2 points are there. So role of AI and ML machine learning in energy systems. So because of the models, there is a significant improvement in renewable energy forecasting and precise predictions. So accurately we can do the predictions of the generation, etc., and distribution of the energy. And also AI and ML machine learning are crucial in optimizing the renewable energy systems, improving the efficiency and reducing the cost through the advanced analytics and predictive maintenance. So for maintenance is also very, very important. And for this data analysis and using the sensors data or real-time data also given by the sensors also can be used. So we can reduce the cost by doing the analysis using the machine learning and artificial intelligence techniques. So what the artificial intelligence is doing in energy sector, that is the next diagram we have. So you can see that the artificial intelligence on the upper side, it is mentioned that it can be used for power planning. For example, we are planning for a generation of renewable energy addition like 20 megawatts or 500 megawatts or 200 megawatts. We are going to plan big solar projects or wind farms. Then for planning, also we can use the artificial intelligence. So production line optimization, then like short-term planning and long-term planning for routing the EV charging points. So to decide the route of the EV charging points, that also we can do. Planning of the efficient and multiple battery usage also can be done. So this is about planning in energy sector. Also the artificial intelligence can be used in energy sector as a computer vision. So computer, we can give the vision to proactive geospatial monitoring of the energy sector. Also defect classification, any fault is there, so that also computer will take care, like classification of the fault or defects. Also computer can be used or it can be given the vision of solar potential geomapping. So geomapping of the solar potential or wind potential, or not only solar but any renewable energy, we can do it. Then machine learning, why and where we can use. So machine learning can be used in like reinforced learning, one of the model or technique of machine learning, which is a subset of RL is a subset of ML. So again I am telling, like reinforced learning, this is a subset of machine learning, can be used for control of the EV charging. Then also the machine learning can be used for grid management, electric grid management, existing grid as well as integration of the renewable energy into the grid and failure prediction. So in case there is a possibility of failure in future, that also can be predicted with the help of machine learning. Then artificial intelligence also can be used for like drone powered fault detection. So drone can be used for monitoring of the long transmission lines or distribution lines or feeders or even distributors. So those conductors we can do the monitoring using the drone. And also the solar cell production can be monitored. Hydraulic turbine welding also can be done. So for this robotics we can use. Again in robotics we have to go for artificial intelligence. So these are the areas. This is a very good picture, like it will show where we can use the artificial intelligence in energy sector, planning in the robotics, like production of the devices, machine learning for maintenance and management of monitoring of the machine learning and computer vision. Both can be used for monitoring and maintenance, electrical maintenance of the grid, even for the management of renewable energy sources after addition. Now, what are the machine learning models? So, machine learning model, we have different models. SVM model is there, then gradient boost model is there, random forest models are there. So, these are called as ensemble models. Artificial neural networks we have got In the neural network models, we have got ANN, artificial neural networks, convolution neural networks, and recurrent neural networks. So these are all the neural networks we have. This can be used for optimization. So for the optimization, back propagation we can use, or feed forward networks we can use. So these are all the machine learning models which can be used in the renewable energy sector or energy sector in general. So evolutionary models are also there, genetic algorithm models, and then we have got the other particle swarm optimization algorithms are also there, which can be used in the energy sector. So this is what we can do. Neural networks can be used for optimization of the resources. Okay, so these are the different machine learning models which can be finding the applications in energy sector or renewable energy technology. Then this is a general diagram. Machine learning, where we can use machine learning, can be used in smart city. Machine learning can be used in autonomous driving or autonomous vehicles, we can say, particularly the cars. And then speech recognition, pattern recognition, computer vision, we can do medical image analysis, we can do. Then statistical learning we can do, natural language processing we can do with the help of machine learning. Now, what are the key applications of AI and ML in renewable energy? Anil, is it audible? It's okay? No problem? Okay. Any issue is there, you can tell me, okay? In between, you can interrupt. So any participant having any doubt anywhere, you can stop or we can have the interaction. Right. So what are the key applications of AI and ML, artificial intelligence and machine learning in renewable energy optimization? So there are two cases I am presenting here, like solar power optimization and wind energy optimization. So solar power optimization, AI models can be used for predicting the solar irradiance. Irradiance is very important, that is solar input to the panels, how the energy can be generated or how much energy can be generated, what is the panel placement or tilt angle. We have to give the tilt to the angle, like tilt angle to the panels for depending upon the longitude and latitude of the site where we are going to install the solar panels. So in our college, Kamla Institute of Technology and Science, we have got 200 kilowatt power plant and the angle of tilt is 17 degrees. Like this, if the site is different, for example, Jayamukhi College, then they may have the different tilt angle. So optimization is required in panel placement and tilt angles. In that, AI can help. Real-time monitoring of the predictive maintenance and performance tuning. For example, predictive maintenance of the solar cells can be done in real time with the help of AI. Then in wind energy optimization, machine learning algorithms can be used for predicting the wind speeds. So tomorrow or after 2 days, what will be the wind speed that can be obtained. Hence, based on the wind speed, will be the energy that can be predicted. Optimizing the turbine performance and placement, where we can place the wind turbine or a group of wind turbines. That location also we can optimize. Real-time fault detection and maintenance scheduling also can be done with the help of artificial intelligence. So these are all the artificial intelligence and machine learning applications in renewable energy. Then apart from this, we can use the AI and ML for energy storage systems. For example, AI-driven algorithms can be used for managing the battery charging and discharging. Also, it can be used for predicting the energy storage requirements and improving the battery life. So battery cell life is very important nowadays. Research is going on. Any faculty or researcher want to do work in this battery cell life prediction, then somebody can work using the AI techniques and different algorithms. So next one is efficient management of grid scale storage systems. So grid scale storage systems nowadays they are available, like using fuel cells and other techniques. So large amount of power also can be saved, but again there are limitations if we think about the entire grid. Then smart grid management. artificial intelligent algorithms for real-time load balancing can be done. Also, it can be applied for predicting the demand and optimizing the energy distribution, how the energy is distributed, and integration of the renewable energy with the traditional energy sources like thermal and other sources. So on the left hand side, you can see like engineer, expert engineer, and right hand side, a computer scientist is there. So clubbing together this like expert in engineer and electrical engineer, we can say that renewable energy will be having the knowledge, and computer scientist can be used for writing the machine learning algorithms for prediction, clustering, and optimization. And renewable energy engineer expert can use it for multi-carriers energy systems, spatial, temporal, and then the circular integration. So these are all the renewable energy related issues, and this can be solved with the help of computer scientists. So that is how the machine learning is applied or is useful for the renewable energy sector. Then next is this is a chart. I am showing the machine learning model, like gradient boost regression model is there. So there is a target property, proper band gap we have to maintain, and for that, like number of inputs is required, and you will get some output is shown in the last column, that is acceleration model. Like two novel materials with ideal band gap and stability are obtained. So this is output. You can say that energy harvesting is our target, or proper band gap is required. Accelerated discovery of lead-free phosphoids for solar cells. So that is the conclusion from this. This is the output. This is our target, and using machine learning model, we are able to get the output. Similarly, energy conversion also, we have the, what is the energy conversion objective? Objective is that CO2 should be reduced, efficiency is to be increased, and therefore we have to create a library of like if you are thinking about the solar power plant or solar or wind and other energy sources, so 12,229 different surfaces we are giving as an input. Then machine learning model is random forest regressor, and prediction is that like this is related to the output, or we can say that data set will be examined. So 4,000 data is exhibited, 12,000 is the input for training this model, and then this is used for testing. 4,000 is the data set used for the testing. So finally we will get the acceleration performance like 2 into higher Faraday efficiency that will be recorded. So this is the output we get. Finally, what we can say, conclusion is given in the last like line, that is accelerated discovery of CO2 electoral catalysts using the active learning. So this is what we get the conclusion from the last line. Similarly, we have got the models. Now I will not read everything here. Energy storage. The model used is agglomerative hierarchical clustering model, and all materials as per the International Council of like semiconductor devices. So all these models will be like materials will be given, and 2,986 like will be examined or the tested, and finally we will get the 3 novel materials which will be having the unparalleled properties, or very you can say that important properties for the battery design. So we get the unsupervised discovery of the unsupervised learning. We can use machine learning technique we are using here, and finally what we get is solid state lithium ion conductors. So this is a final recovery of the study conclusion. Energy management also, our target is optimized automatic generation control. For this we are using the relaxed deep learning model, and the performance or the output is around 80% cost is reduction is possible. So power grid optimization using the relaxed deep learning also can be done. So this is another deep learning, is another like subset of the machine learning. Next, AI and ML in energy forecasting. So just before we were discussing, like after like 3 to 4 slides before, we were discussing that weather data can be used, historical trends can be used for prediction of output, for example solar radiation and wind speed, etc. Other things, other parameters also we can take include. Then energy demand forecasting, like machine learning models can predict daily, seasonal and long-term energy consumption. So based on the consumer's behavior for 2 years, 3 years, 5 years, 10 years, the machine learning models also can predict or forecast the energy demand. Like whenever the Christmas is there, then what will be the demand, etc. Any festival, New Year celebration is there, then that can be like patterns of the behavior can be given, human beings behavior can be given to the model, and model will predict or forecast the demand, energy demand in the future or near future. Benefits of forecasting. So what is the benefit of forecasting the energy generation and demand? That it reduces the energy wastage and it helps the utilities to plan better for the demand fluctuations. So these are the two benefits we get by forecasting the generation and demand by using the artificial intelligence and machine learning. Then AI innovations in energy forecasting. So there are two categories. On left hand side you can see solar forecasting, and then right hand side there is a wind energy forecasting. So this is a general process, like we require to gather the data. Here also same thing, everything is same on left and right side. So we gather the data here solar. Here we will gather the data of wind. Then we have to clean the data. Okay, data pre-processing is required. Suppose we have got the data of say 100 million values .csv files. Then we get the data may not be, sometimes it is missing. Some values may be missing. So therefore data pre-processing we have to do. We have to like feature extraction you have to do, normalization you have to do, and you have to remove the unwanted data or extra data. So that process is called as data pre-processing. Then model we have to train. So once we get the data set, suppose say 100 million values we have got, then out of the 100, suppose 95 million or some 99.99 million values we have, then some values can be kept for training the data out of 90. For example, out of 90 we give some data set for the training and some data set for the testing. So that is how it is done. Model training is required. After model training is done, there is a assessment of the model's performance. So on the unseen data, and fine tuning can be done for better accuracy. And finally we get the forecasting of energy production, and prediction and optimization of the demand also can be done. Demand also can be optimized. Location also can be optimized. Forecasting of the wind energy production also can be done. Wind and solar. So these are the two cases I am showing on the same slide, solar energy and wind energy. I will share this PPT afterwards. You can go through this, the important slide and the entire PPTs. Next one is case study. So just now we have seen solar and wind. So we have got the use case here. So case study, first one case study is, for example, is Solar City, Tesla, of the Tesla company. So they are using the artificial intelligence to predict the solar energy generation based on the weather forecast. AI algorithms also can be used for optimizing the energy consumption in real time and residential and commercial users. And also integration of solar panels with the smart grid systems can be done to optimize the distribution. Now what is the impact of the application of AI in Solar City, Tesla? That is improved energy efficiency. Around 30% improvement is there in the efficiency. So 30% efficiency improvement is a very good achievement, we can say. That too with the help of artificial intelligence as compared to the traditional systems or traditional solar plants. Then there is a reduction in the cost for the consumers and utilities also. So what are the applications of AI in solar energy production? Solar irradiance can be forecasted. So what will be the solar irradiance tomorrow or day after tomorrow? That can be done. Forecasting can be done. Predictive maintenance can be done. Energy storage and integration can be done. Optimal solar panel orientation like tracking. So in the tracking, solar tracking, we have got two types of tracker. One is called as vertical axis, another is called as horizontal axis, and the tracking can be done. So we can move the solar panel in 360 degrees, and based on that, we can optimize, and we can say that maximize the energy generation from the solar. So there will be around 7 to 9% of 7 to 20% sometimes we get the more energy production because of the tracking as compared to the regular power plants, fixed panel type power plants. Then solar energy radiation data that can be pre-processed. Some data will be used for the training, some data will be used for testing, and then we get the solar forecasting model is ready, and then we get some loss in the training, and also we get the forecasting results as a performance evaluation of the system. So system performance can be evaluated with the help of this machine learning algorithm. So these are the steps we have to follow. We can use the forecasting results will be the output, input is the solar radiation data for this machine learning models. Then we have got artificial intelligence in wind energy. I have taken two case studies. One is solar and wind, because majority of the renewable energy sources are based on the solar and wind. Therefore, two I am just presenting here. So next example is Siemens Gamesa. So this is AI systems used for turbine performance monitoring and predictive maintenance, and machine learning algorithms for optimizing the wind turbine and placement of the minimizing the energy loss and even the placement of the turbine, etc. Then reduce the downtime, that is the impact, and maximization of the energy generation for the wind turbines. So that is the result of the application of AI, artificial intelligence, by Siemens under the Gamesa project, or we can say that by the Siemens company. So this is another case study. Then this is applications of BESS and HESS in wind turbine system. So we can go for voltage control, frequency control, power factor correction, and power smoothing can be done. Like if there are any fluctuations in the power or generation, that can be done with the help of this one. Okay, like harmonics will be the problem in wind turbine, wind output, so that can be, power can be smoothing of the power can be done. Next one, benefits of the artificial intelligence and machine learning in energy optimization. What are the benefits we'll discuss in the next two slides, this slide and next slide. So increased efficiency we get, cost reduction we get, and grid stability we get. So these are the benefits. Okay, by better like forecasting of the energy production, real-time optimization of generation and distribution, we can increase the efficiency, and also we can make the grid stable. So AI can be used for load balancing. Load balancing is very, very important for stability of the system, for both power angle stability and voltage stability, and even with the help of fluctuating renewable energy sources, we have to maintain the grid stability. For these situations, we can use the AI and ML in the renewable energy optimization. Next benefit we get is improved energy storage management. So battery system like charging, discharging, etc. Management of the battery more efficiently can be done, or better integration of the in the grid. So that is what we get. Now, what are the success stories? What are the success stories of AI and ML, artificial intelligence and machine learning in RE, renewable energy sources? So Google's DeepMind, everybody knows about Google company. They have got this software developer DeepMind, and they are using this, like another one software is wind energy in UK. So DeepMind is used in UK for solar, and there is another wind one. So wind energy is also there. So they are using in UK, and they are able to get increase in the 20% efficiency. So that is the advantage of using artificial intelligence. Google's DeepMind 20% efficiency is improved. So this is what we get the benefit of using the artificial intelligence in the renewable energy. Then similarly, similar to the Google's DeepMind, we have got other success stories, like another success story is IBM's Watson and Solar Energy. So again, this is used in IBM's Watson and Solar Energy. This is a artificial intelligence model. This is practically used in Ireland. So we have got, again, this is coming. So Siemens Gamesa predictive maintenance already we have discussed. Tesla is using the artificial intelligence in management of the energy. So Tesla are having the solar power plant, solar cities there. So there we are using this artificial intelligence for management of the energy. Complete management, like energy demand prediction, then production prediction or forecasting, etc. For everything related to the energy of the solar city, they are using this. Then in Australia, before that Australia, we have got Ireland. In Ireland, AI-powered solar forecasting is done at IBM Research. So they are using in Ireland. Then in South Australia, there is autonomous microgrid using the artificial intelligence techniques. Then AI techniques can be also used by Microsoft. So they are using, Microsoft is using Project Natic. So they are using this as a AI-based energy management in the smart buildings. So they are using this for different purposes, as you can see here. Then there are some other success stories like artificial intelligence enhanced predictive maintenance in wind farms, that is done by GE, General Electric Company, GE company, for GE Renewable Energy Company. AI-based energy storage optimization is done by the Tesla. So Tesla is using artificial intelligence for different applications. Then AI-driven grid management is used in Germany, that is 50 Hertz. And then AI-enabled optimization of the hydroelectric power plants is done by Voith Hydro. So this is in Canada. They are using this particular artificial intelligence for optimization of hydroelectric power plants in Canada. So then there are challenges in the limitations. What are the challenges of using the artificial intelligence and machine learning in renewable energy? So these are the challenges, and some limitations are also there. So data quality and availability is a challenge. AI models require large amount of and high quality of data for performing effectively, for accuracy of the model and the output of the model. So lack of standardized data in some regions is a challenge, and it's also limitation. It's a limitation on the application of AI. Complexity and cost. So initial implementation of cost of the AI-based systems can be very high, and the models are complex. So machine learning models are complex. They require skilled professionals to develop and maintain the AI models or machine learning models. And then integration with the legacy systems. So there is a difficulty in integration of the AI technologies with the existing grid and infrastructure and the renewable systems. Next one, what are the future trends? After this, I have got 3 to 4 slides. So future trends in AI and renewable energy. And then after this, I will discuss about the emerging trends also. So AI-powered smart grids, we have got, there is a development of the AI-driven systems, okay, which can be integrating the renewables and maintaining the grid stability. That is the main purpose. And this is autonomously done. That is very important. Autonomously, automatically the balancing of the load, etc., that will be taken care of. Then enhanced predictive analytics. So more sophisticated weather forecasting and energy production predictions can be done with the help of AI. That is the future trend. In future, we are expecting that. And then another future trend is that greater adoption of AI for long-term planning and energy transition strategies. Transition strategies means from fossil fuel to renewable. Then these are the emerging trends we have. Edge computing can be used for energy systems, artificial intelligence in decentralized energy systems, for example, the solar power plants, distributed generation systems like wind farms, etc. RL, which is a subset of reinforced learning, which is a subset of machine learning, can be used in renewable energy optimization, the whole system. Energy forecasting with the machine learning can be done. XAI, this is another one, AI, XAI, artificial intelligence for renewable energy decision support can be done. AI enhanced predictive maintenance for the renewable assets can be done. That is the emerging trend. And then another emerging trend is optimization of microgrids with the artificial intelligence. Then grid management and stability with the RL, okay, reinforced learning, and integration of artificial intelligence in renewable energy storage. So what are the future prospects? So definitely the future of the artificial intelligence and renewable energy combination is bright. You can say that marriage is already done for artificial intelligence and machine learning applications in renewable energy. So it has got very bright future. And quantum computing can be used for better neural networks can be done. And then additionally increasing the availability of big data, improvements in data analytics with enable to more accurate and efficient AI models. AI and machine learning technologies continue to evolve. They are expected to play a pivotal role in the transition to a sustainable and resilient energy source. Resilient means without any fault or any problems are coming, then automatically the system should overcome those faults. Conclusion, this is the last slide, last slide I can say. Artificial intelligence and machine learning, the key enablers for the future renewable energy are artificial intelligence can significantly enhance the efficiency, scalability, sustainability of renewable energy systems, and AI technologies can evolve, they will continue to play a critical role in optimizing the energy production, storage and distribution, and collaboration between the tech companies, utilities, governments is essential for unlocking the full potential of artificial intelligence in renewable energy. So thank you for giving me this opportunity. I thank Professor Anil, HOD of EEE Department in Jaimukhi College of Institute of Technology and Science. Thank you for giving me this opportunity. Now the session may be open for questions or any doubts are there. I think I am audible.
Yes, sir. Yes, sir.
Okay. So I will stop sharing. Anybody is having any doubt, we can go to the slide. No issues. I will keep it sharing for some time. No doubts? Then additional input from my side is that in Python we have got PV library, so that can be used as a suitable tool for the computers to what is the solar panel or etc. So that PV library can be used by the engineers and the computers. Then solar everywhere or anywhere. This is a company. Solar Anywhere is a company which will give the sales information about solar sales information and the location of the sites for future. So based on the data, standard data, so that can be used as one of the AI tool in the solar energy forecasting. Apart from this, for wind generation, Wind Pro is there and NREL. So these are the wind tools, AI tools available in the market, or we can say that available for research. Azure is a Microsoft machine learning cloud-based platform from the Microsoft company. Just now I told that can be also used for predictive maintenance of renewable energy sources. TensorFlow is an open source machine learning library made available by Google. It also helps in many ways like predictive maintenance in the energy sector. Grid Bundler is a smart machine learning in renewable energy models to help the power companies. in the maintenance as well as the solar panel and battery maintenance, etc., and managing the entire grid. So these are all the few artificial intelligence tools. Energy Plus is also there. MATLAB also can be used for demand side management or demand forecasting purpose. Thank you for giving me the opportunity.
Sir,
I am thankful.
sir,
Uh,
session up to 5 p.m. Sir.
okay.
Explain any base paper, sir. Any base paper.
Base paper. Base paper. Okay. Regarding the presentation, you are asking. Regarding presentation. Just 1 minute. Can I take a break? Just 1 minute. Give me some time.
Okay, sir.
Okay. Anybody having any question? You can.
Hello.
Hello.
Hello. Hello.
Hello.
Hello, sir. Can I ask one question, sir? Please.
Oh, definitely.
Sir, how can AI can predict the blackouts in distribution system, sir? If blackouts is it will be going to be happen. How AI it will be predict and how can we aware of overcoming the blackouts? Can you explain, sir? Means AI means that it will predict the blackouts. Maybe I'm thinking that it will be going to be predict the blackouts and we can prevent the blackouts. Is there any method is there in the AI for this?
Just 1 minute. See, actually, for if this artificial intelligence and machine learning is based on data, okay, previous data. Everything is based on data because it is not like human intelligence that we can predict something without having any background. So, if any data, previous data is available for the distribution system regarding the blackouts, then it may predict. Otherwise, it's not possible. You should have sufficient data for training and testing. After that, if anything is going to happen, then it will predict. Okay, blackout will not be predicted. It is like demand based on the patterns of the behavior and usage pattern of the consumers. It can predict the demand and it can also predict the generation. But blackout prediction, as far as my knowledge is concerned, is not possible.
Not possible. Means blackouts means it will be anything, anytime it will be going to be happen. We cannot
Yes,
predict that.
it will happen anytime. It is, we don't know. Actually, blackout is a very dangerous situation. It
Sir.
should not happen actually, but because of the some failure or some like cyber security attacks, sometimes one case was predicted in like it was came in news in Brazil because of the cyber security attack. The complete blackout was there in the grid. Okay. But it
Okay.
was not predicted because it is a cyber attack. It was not predicted by artificial intelligence and other techniques.
Means it will be an AI, no, sir. We are giving data to the AI and machine learning.
If
Maybe
the
it will be
previous
changes in
data,
the data. We can.
no, if it is previous data is there, failure data is there, and if any sensors are placed in the distribution system, that sensors are giving some inputs, then it may predict. Okay, it is based on the data only.
Okay.
Okay,
Okay, sir.
without having background data, it will not be able to predict.
Okay. Okay, sir. Thank you.
If any circuit breaker is intelligent circuit breaker is there or relays are there, digital relays are provided, then if the possibility is there that the relay is going to fail, the sensor will give some information, then it will be predicted. Okay.
Means.
So it
Sir,
is based on the data only.
hmm. If
Without
we are
data,
having.
without having any input, it will not predict anything.
Hmm.
So that is
Means
how it will work. Okay.
our relays and circuit breakers is far away better than this AI and machine learning. Means.
Yes, you can say like that.
Okay. Okay, sir.
Okay. Sensors we have to place. Based on sensors, it will operate.
Okay. Based on
Even
sensor.
circuit breakers are not predicting. Okay, they are not predicting.
Hmm.
Yes.
It will be acting at the situation.
Yes.
Okay.
On spot, it will act immediately. It will take care. That is okay. After fault is occurred, but without before fault occur, it will not say that tomorrow there will be a fault at morning 6:30. Okay, it will not predict like that. Prediction means whatever is going to happen in future, you should get the before information.
Okay. Sir,
Okay.
if we are giving total data to the AI system, when we are introducing in our distribution system, we are giving total data to the distribution system. We are keeping on the online our information.
Exactly.
Our if anything, just now we talk, you have told that cyber attacks, anything, it will be the hacking or malfunctioning of the equipments. It may be happened, sir, in these coming AI and distribution, AI and AML system.
No, actually it is a starting point of the application of AI in renewable. Okay, so just people have started before 2018. Actually, Tesla Solar City they are using the artificial intelligence since 2018. Okay,
Mm.
so very recently, 2018 means you can say just 5 to 6 years before they started using, and there is no report so far that the cyber attack has been taken on the artificial systems, AI
Mm.
systems. There is no report like that. Okay.
Okay. Okay, sir.
Okay. Any other question? Otherwise, as Anil sir told, I will show one paper. So I am showing the paper, the paper referred, one of the reference what I have used. Anybody want to ask question? You are welcome. So this is a paper. Just now I have gone through this paper. So they are saying that artificial intelligence and machine learning for sustainable development. What is that the AI is going to do? That is explained here. So this is what the concurrence analysis of keywords in literature. So that is general. This is a general diagram. You can see here, this is like efficient use of the utilization of energy. That is a red cluster. So that is regarding the utilization. Okay, that is mentioned here. Then blue cluster, it will be like ML and predictive modeling, machine learning and predictive modeling is the blue one, this one. So supervised learning and unsupervised learning, two learning patterns will be there, and they are going to use this one. Now, what are the AI and ML techniques that is explained here in the table 1? You can see here that is the artificial neural networks. So models inspired by the brain of neural structure used for recognizing the patterns and making predictions. So predicting the energy production and usage optimal utilization means what? Say you should have the lot of data like thousands of values you should have, 10,000, 20,000, 30,000 values you should have. Then the inputs will be given to the artificial neural networks, and ANN, artificial neural networks, will be the prediction of the energy production. So what will be the energy in 24 hours? Or maybe more than 24 hours, like 1 to 10 days, 0 to 10 days, that is the prediction we get in energy production. Then optimal location of the energy sources. So optimal sources, how to optimize the location of source, that is also important. I will give an example, like in one of the state in India, they kept the wind farms on the hilly area, but that was not the correct location, and the entire investment got, like money of the government was wasted. So this may happen to any site or location, and based on that you have to choose based on human intelligence as well as the artificial intelligence. Now we have the AI, so we can use AI for that application. Next one, support vector machines, SVMs. So this will be having supervised learning algorithms. Supervised learning algorithm means the data will be classified. For example, we have the voltage values, current values, and the real power, reactive power, frequency. All these values we have, like load flow studies. So each and every parameter is defined. So we can say that the data is labeled data. And labeled data is the basic requirement in supervised learning and regression analysis. So based on that, the category of the energy generation or type and forecasting can be done based on using the SVMs, support vector machines. So this is called as the supervised learning algorithms. Okay. Data should be classified data, or you can say that labeled data. You should have labeled data. So that is what we get in the support vector machines. Next one is decision trees. I think this is visible, paper is visible, anybody can confirm. So
Only
paper is
showing, sir. Remaining this one.
okay. So third point is decision trees. Now decision tree means you should have, like in case of artificial neural networks, we will have 3 layers. Okay, input layer and weighted layer and output layer. But in case of decision tree or deep learning, we'll have more than 3 layers. So that is called as deep learning, and it will take the decision, and that will be the accurate decision. So the decision will be in the form of this technique will be in the form of like a tree structured models for decision making and analyzing the outcomes. But the accuracy as compared to artificial neural networks, the decision trees will give more accuracy. See, you can see the point number one, the artificial neural networks, ANNs also can be used for predicting the energy production, and decision trees are also used for forecasting the energy consumption and the production. But the difference here is that ANN has got less accuracy and decision trees has got more accuracy. So accuracy is better. I cannot say that the ANNs are not accurate, but accuracy is compared to ANN, this deep trees has got more accuracy. We can say more accuracy. Okay. Then random forest, this is another technique, AI technique, artificial intelligence technique. So this will be ensembles of the decision trees. So similar to the decision tree for improved classification and regression accuracy. So again, accuracy is improved here, enhancing the accuracy in energy load predictions and evaluating the renewable energy systems performance. So that is application in renewable energy. Then reinforced learning, RL. So this is a subset of machine learning. Okay, it is not like separate. Reinforced learning means it is not separate. So it is one of the technique in machine learning methods. So these are the learning methods that optimize the actions of the rewarding desirable behaviors over the time. For example, this reinforced learning means that we will have the reward will be given to the program whenever it is giving the correct output. So that is based on this. For example, there is a dog. Imagine that there is a dog. So dog is here is your program, reinforced learning program, machine learning model, for example. So dog is to be trained. Suppose we are throwing the ball and 3 times the dog has catched the ball. Then we can say that reward should be given and 1 or 2 biscuits will be given to the dog. So that is how the reinforced learning is going to work. Okay, this is called as reinforced learning based on the rewarding to the dog. Now dog in this case, what is the hypothetical situation I told, but here it is dog means the reinforced learning model. So model will be rewarded. Then what is the advantage? Advantage of the RL is reinforced learning is that it will give the real-time energy grid management, autonomous control of the energy storage solutions also. So automatically real-time data will be available on display, that is the output, and grid can be completely managed. At the same time, this is used for reinforced learning, also can be used for autonomous control of the energy storage solutions like batteries and other storage systems. Then we have got genetic algorithm. So this is used for optimization. So genetic algorithms are used for optimization. Optimization techniques inspired by natural selection processes. So like chromosomes, Y chromosome, X chromosome, based on that, you can say genetic algorithms will be working. And they are suitable for designing the efficient renewable energy and optimizing the wind farm layouts. So layout of the wind farm can be optimized with the help of genetic algorithm. Then we have got another technique that is called as deep learning. So deep learning, again, number of layers as compared to the artificial neural networks, we will have 7, 10, 11 layers will be there, and based on that it is going to work. This model is going to work. Deep learning is going to work. Now what is there in this deep learning? It is advanced neural networks with multiple layers of more accurate predictions and pattern recognition. So it is used for improving the solar power forecasting and with good accuracy, highest accuracy you can say that, and identifying the trends in the extensive energy data. So it is like we can say that it is like unsupervised learning. You get lot of data, you give the lot of data to the deep learning model, and it will give you the some pattern. It will come out, output will come. For example, the energy for the next 24 hours hourly basis, this will be the energy, that will be the output. If you give large number of data without any labeling, whether this is a voltage column, then frequency column, then real power, reactive power, etc., that I told just now. So that is required for supervised learning, like support vector machines. But in deep learning, you don't require that classification. So you can say that unclassified data, whatever the raw data is there, directly you can give to the deep learning. It will develop its own pattern and it will give the result. So that is how the deep learning technique is going to work. Okay. So this is used for improving what is the application of deep learning in renewable energy sector? That is for improving the solar forecasting accurately and identifying the trends in the extensive energy data. So energy data trend, like next 24 hour, morning 6 to 2, day after tomorrow morning 6, 24 hours. What will be the 1 hour each one data, the output of the solar that can be predicted using the deep learning. But you should have lot of data for training and testing before. Then next technique is used as a fuzzy logic technique. So these are the systems which will handle the uncertain and imprecise information, enabling the partial truth values. So this is partially true, it's not accurate one. Fuzzy logic nowadays has been used in the washing machines also for like stopping the water flow or tap, or you can say that adding the washing powder, etc. For that purpose, we are using the fuzzy logic based on the type of the cloth and the volume of the cloth, number of dresses. Suppose 5 to 6 dresses are there, 5 pants, 5 shirts. Then the fuzzy logic will take care how much powder to be poured and how much water is to be poured. So that type of machines are available in the market. So fuzzy logic based the washing machines. Similarly, the fuzzy logic can be used in renewable. Now we are discussing about the renewable. So let us discuss about the renewable sector. So managing the uncertainty in the energy, like energy mix, controlling the complex renewable energy systems. That is what it is done. Then clustering algorithm. So this is another technique. Again, it is unsupervised learning. Unsupervised means the raw data will be given, unclassified data will be given, and it is going to group in few types. For example, 5 voltage values, 5 values are for real time, real power, 5 values for reactive power, 5 values for frequency. That is going to give you the output. That particular technique is called as the clustering algorithm technique. And the application of this technique is that detecting the energy consumption patterns, segmenting the different types of renewable energy sources. Segmenting means you can one after the other sequence, you can keep ready for the solar, next is wind, next is hydrogen, next. So that will be pattern of the operation and putting into the system or keeping into the system, that will be done. So that is the use of the clustering algorithm. Then Bayesian networks. So this is another artificial neural network technique or AI technique, we can say. This is a probabilistic model showing the variables and their conditional dependencies. And risks in the renewable energy projects, modeling uncertainty in the renewable energy output. So that these are the different techniques. Ensemble learning is also there. Regarding clustering, again, one more point I can tell you that clustering means grouping of the some atoms. For example, in one container we have the number of pens and number of pencils and number of erasers are there. So pen means one group, pencils means another group. Then we have erasers in another group, and then we have got sharpeners, another group. So if all the atoms are kept in one group, one container, how to separate them group wise? That number of pens in one group, number of pencils in one group, number of erasers in one group, number of sharpeners in one group, like that. We can club together. So that is how it is done in the AI technique, and that technique is called as the clustering technique, clustering algorithm. And that is used for detecting the energy consumption patterns of the human beings in the distribution system or locality, whatever the locality or substation is there. So that will be done. Okay. So ensemble learning is also another technique which is used for combining the multiple algorithms to achieve the better predictive performance. Again, accuracy is better. here accuracy is improved, we can say. Increasing the robustness of the energy predictions, merging various forecasting models for improving the overall performance of the system. So that is how it is done. Okay. Then the time series analysis. So these techniques are for analyzing the sequential data points over the time. It's just like it is a real time versus real power versus time and voltage versus time. If somebody wants to do the analysis, that technique is called as the time series analysis technique. So I think I have completed. One more, if you want, I can continue. Anil?
Wait a minute, sir. Wait a minute, sir.
Okay.
Sorry, sir. Wait a minute, sir.
Okay. So models, ML models, linear regression models, etc. Those can be done. You can see here models,
Thank you.
ML applied.
Thank you, sir.
Okay. Still, if you want continue, I can continue.
No problem, sir. Enough, sir. Thank you, sir.
Okay.
Sir, thank you, sir. Thank you for your valuable information about AI and development of AI and ML models for is renewable energy sources optimization. Thank you, sir. Thank you for your valuable information.
I will stop presenting.
Okay, sir.
Tell you.
Okay, sir.
Okay.